The PMAX project started with a request from one of Stena Bulk's clients. They wanted to carry 54,000 tons of gasoline into New York Harbor. New York Harbor has a draft restriction of 11.3 meters, and since these vessels have a length restriction of 183 meters, we have to make it quite wide. That's the MAX concept.
For the PMAX vessels, the pre-contract process contains three different subphases mainly. That is the idea, the concept idea, the development of the outline specification, and the concept design. The concept design is based on a number of competence areas, and one is machinery and systems. Typically it's electrical piping, machinery and so on. Another competence area is steel and surface protection, which is the hull structure, painting, surface preparation and so on. The third one typically is hydrodynamics and ship stability. Considering that you aim at bringing in, say, 30% more cargo in one delivery to New York, then you can try to figure out how can you do that. You can of course make a longer ship, but then you have length restrictions in New York Harbor. Then we have a limitation of the draft, so that what we could do is to stretch the beam of the vessel from the typical Panamax 32 meters to 40 meters in this case. And that was a continuous development together with Charter and Stena Bulk Concordia Maritime.
My job in this project is to take care of structural issues of the design. That is, in simple terms, to make sure that the ship is strong enough to withstand the forces. Each new project has its own challenges, and in the case of the PMAX it was the size of the vessel which was new to us, so we didn't have so much experience to rely on, and also the unusual dimensions with a low length to beam ratio and a hull girder with low height, which makes it less stiff and, simply speaking, weaker, so the forces had to be taken care of in a different way. For a hull girder with a limited depth, you have to compensate that with a thicker plate, basically. The stress flow must be more carefully taken care of, and higher attention to the detailed design in order to avoid stress concentrations.
Stena has very good experience from an earlier project called VMAX. Two VLCCs built with a very wide beam and shallow draft concept. So for the PMAX project we could benefit from the experiences and the work done for that earlier VMAX project. That was also the solution for this project, to have a twin screw, twin skeg propulsion solution. That meant also that we could have a twin steering machinery installation, twin rudders, and we decided also to go for 2 engine rooms, completely separated. And as a consequence of all these decisions, we could end up with a ship with complete dual redundancy, and that is quite an achievement for a tanker like this. So the safety aspects, proactive safety, is coming with the hydrodynamic design and the beam of the ship. So that is a part of this PMAX thinking and concept design.
After the conceptual design is completed, the naval architects and chief engineers develop outline specification consisting of some 50 pages. These pages describes the type of vessel and the main requirements of the vessel.
So once we have completed the outline specification work, that document is released together with a tender request to a number of shipyards. One after the other one, we visited the shipyard to assess, and in this case with the P-MAX, it's quite a significant design work to be done, whether they had that capability or not, and also the production facilities and the financial and delivery capabilities. Among these 5 shipyards, we ended up with one that was the most competitive, and that was Brodosplit shipyard in Croatia.
One key factor in order to run a successful project is to make sure that the technical specification is written in a very clear and precise way. We have been running more than 30 projects in the last 10-15 years, and not one of them have been exposed to litigation or arbitration. That is not only good luck, but it's also due to a good team.